Hello, class, and welcome to part 5 of Topographic Maps. In this section, we will be going over slope and gradients. Now, when we're talking about slope and gradient, you guys might be familiar with slope from math, where it is the change of y over the change of x, okay, in a line function. Now, slope is how quickly the elevation of the land changes. Now, in the picture below here, we see a grassy knoll, and we see people walking up of it. Okay, this is a steep slope. When we look at the map below, how do we distinguish how something is steep by looking at the contour lines? The more closely spaced the contour lines are, the steeper the slope of the land. So think to yourself, where is it steeper on this mountain? Okay, which way would I want to hike up this mountain? Would I want to come from the direction of A or come from the direction of B? So the steeper side would be B, okay, where we have the lines that are more closely packed together. It means we're changing our elevation over a shorter distance. As if I was coming from A, it would be more gentle. Okay, the more widely spaced the contour lines are, the more gentle the slope is. Okay, so I might have to walk a little bit farther if I came from A, but I won't be changing elevation as fast as I would from B. So from A, we have our gentle slope, and from B, we have our steep slope. Now, which mountain on the map below has a steeper slope, and how do you know? Now, there are two mountains on our map. We have Eagle Mountain and we have Crow Mountain. Now, when you look at both of these, you should pick Crow Mountain. Crow Mountain's isolines are more tightly packed together. Okay, Crow Mountain has a steeper slope than Eagle Mountain because the contour lines are closer together when we look at Crow Mountain. Now, this leads us into how do we calculate the steepness of a slope. Okay, it's the same thing that we did in math, where we're going to change watch the change in y over the change in x. The change in y is our change in elevation. Our x is going to be our distance. So gradient is how rapidly a field value changes over a particular distance. Now, remember we talked about field before in one of our previous sections. Field value is just the value of what you are measuring, okay, that you plot on a map. Okay, and on a topographic map, our field values are going to be elevations. So when we see the equation here, so this is the equation for gradient, and you can find it on the front cover of your Earth Science reference tables. Gradient equals the change in field value over distance. Now remember in the previous slide, it said our field value on a topographic map is going to be elevation. So I can reword this to say the change in elevation over distance. So we're going to use ISO lines on the map to figure out where our field value is, and then we're going to use our straight line distance to measure distance. Let's say a straight line method to measure distance. So, and then we're going to use our map scale. So an example problem. Point A and point B are locations that are 0.24 miles apart on a ski slope in northern New York. Point A has an elevation of 1,560 feet, and point B has an elevation of 1,800 feet. What is the gradient between these points? Okay, and we're going to show your work. Now, normally in class, I'd have you guys work on this independently, but I'm going to walk you guys through the process right now. So we're going to remember our equation. Gradient equals the change in field value over distance. Okay, in other words, the change in elevation over distance. So we want to calculate the change of elevation. We're going to take 1,800 feet and subtract it from 1,560 feet and divide it by 0.24 miles. Now you can reference the word problem above, okay, if you want to see how I plotted these values. So I'm going to do the math. 1,800 minus 1,560 feet, okay, is 240 feet. Now I'm going to take that 240 feet divided by 0.24 miles. Now when I divide the values, okay, the value will be in our answer, but the units, okay, feet and miles. Miles cannot cancel out feet, and feet can't cancel out miles, so we're going to carry those values into our answer. So when we take 240 divided by 0.24, we get 1,000. Okay, and as you see it before, as I was talking about our units, okay, it's going to be feet per mile. So for every mile we move, we're going up 1,000 feet. Okay, we're going to determine the gradient here, and I'm going to walk you through the process. Determine the gradient between B and D on the map below. Now, B and D, okay, we know what those lines are because they're on index lines. We know their values and their elevation. We're going to set up our equation. Gradient equals the change in field value over distance. Again, our field value on a topographic map is elevation. So our change of elevation is going to be from 100 to 50. Okay, and then our distance is going to be a straight line from B to D. So we're going to take out that piece of scrap paper, put it on B, make our mark, put it on D, make our mark, and move it down to the scale, and we see it's 2 kilometers. And we're going to plug that into our distance on our gradient equation. So 100 meters minus 50 meters divided by 2 kilometers. We simplify this equation to be 50 meters over 2 kilometers. Now, when I take 50 meters and divide 2 kilometers, my answer is going to be 25 meters per kilometer. So for every kilometer I walk forward, I'm going up 25 meters, or down 25 meters if you're going downhill. The topographic map below shows a stream crossing several contour lines, passing through points X and Y. Now the elevations are measured in feet. What is the approximate gradient between point X and Y? So we see where X is and we see where Y is. Now Y doesn't have an elevation on it, so first thing we're going to need to do is figure out the contour interval. Here's our equation for gradient. Okay, we have our line for 50 for X, okay, and our line for Y. Now, if I'm going from 400 to 500, okay, I'm going to see that, I'm going to get rid of that for a second. There's a difference of 100 between these values. Now I have 1, 2, 3, 4, 5 spaces. 100 divided by 5 is 20. So that's why we're going to have 420 as our Y elevation. Okay, and this is going to be in feet since our scale is in miles. So when we plug in the values for our field value, or our numerator, okay, it's going to be 500 feet minus 420 feet. The next thing we're going to need to do is measure our distance. So we're going to mark X and Y because the river's pretty straight as it goes through. Okay, and we're going to use our scale on the bottom here to see that it's 2 miles. We're going to simplify the numerator. 500 feet minus 420 feet to be 80 feet. And we're going to divide that by the 2 miles. So 80 divided by 2 is 40. And our units will remain as feet per mile. So in other words, for every mile I'm walking, I'm going up or down 40 feet in elevation. Another checkpoint. The topographic map below shows a hill of points X and Y. Points X and Y represent location on the hill surface. Elevations are shown in meters. What is the gradient between points X and Y? So Y is already labeled for us, but first we're going to provide our equation. Again, that equation is found on page 1 of your Earth Science reference tables. So we have Y, but we need to figure out what X is. And we need to find out what the contour interval is. Okay, so if Y is 300, X is 400. We have a difference of 100 meters between this index line and this index line. We have 1, 2, 3, 4, 5 spaces. So 100 divided by 5 is 20 meter intervals. Now, if this line is below the 400, we know we're going to subtract 20 from the 400 to see that X's elevation is measured to be 380 meters. Okay, once we have this information, we're able to put it in for our numerator of our equation. So gradient is equal to 380 meters minus 300 meters. The next thing we're going to need to do is find out what the denominator value is in distance. This is a straight line, so we're going to put our scrap paper on X and Y, make our marks, and use the scale. Now it shows us to be 2 kilometers. So we're going to plug the 2 kilometers into the denominator, and we're able to simplify our equation to get our answer. So 380 meters minus 300 meters is 80 meters divided by 2 kilometers. When I take 80 and divide it by 2, I get 440 meters per kilometer. Okay, this is our gradient.